The Big Bang is widely believed by most scientists as the main theory that explains the origins of the universe, how everything was made, including the stars, the planets, and everything that lives on those planets like us. Even though it's a bit of a silly name for such a huge event, the Big Bang definitely describes what it might have been like. At first, there was nothing but densely packed particles all crammed into a space smaller than a pinhead. From this single point, a huge explosion of matter occurred, known as the Big Bang. That's just a quick summary of what happened over billions of years. However, despite the continuing popularity of the theory, essentially every prediction of the Big Bang theory has been increasingly contradicted by better and better data. For that reason, when NASA launched the James Webb, the largest and most powerful space science telescope ever built, into space, scientists expected the telescope's data would support the Big Bang theory. Sadly, after just 1 year in space, the Webb telescope is blowing scientists away with its keen eye on the universe. The $10 billion gamble has captured unprecedented images so far back in time, revealing the existence of galaxies so old that they could shatter all we've known about the very origins of the universe. Join us as we dig into the James Webb Telescope's terrifying discovery before the Big Bang. The story begins when we have a groundbreaking new view of the cosmos from the James Webb Space Telescope, a view the world has never seen before. Astronomer Rohan Naidu was at home with his girlfriend when he found the galaxy that nearly broke cosmology. As his algorithm dug through early images from the James Webb Space Telescope, JWST, late one night in July 2022, Naidu shot to attention. It had sifted out an object that Naidu recognized was inexplicably massive and dated back to just 300 million years after the Big Bang, making it older than any galaxy ever seen before. This was such a huge shock to him that he had to call his girlfriend over right away and told her, "This might be the most distant starlight we've ever seen." After exchanging excited messages with one of his collaborators, with lots of exclamation marks, Naidu got to work. Days later, they published a paper on the candidate galaxy, which they dubbed Glass Z13. The internet exploded. It reverberated around the world. Naidu said the discovery of this galaxy, just weeks into JWST's full operations, was beyond astronomers' wildest dreams. JWST, the largest, most powerful observatory ever launched from Earth, was built to revolutionize our understanding of the universe. Stationed 1.5 million kilometers away from earthly interference and chilled close to absolute zero by its tennis court-sized sunshade, the telescope carries a giant segmented mirror and exquisitely sensitive instruments that were designed to uncover details of cosmic dawn never before observed. This is a scarcely probed era, no more than a few 100 million years after the Big Bang, in which the very first stars and galaxies coalesced. How exactly this process unfolded depends on exotic physics, ranging from the uncertain influences of dark matter and dark energy to the poorly understood feedbacks among starlight, gas, and dust. By glimpsing galaxies from cosmic dawn with JWST, cosmologists can test their knowledge of all these underlying phenomena, either confirming the validity of their best consensus models or revealing gaps in understanding that could herald profound new discoveries. Such observations were supposed to take time. Initial projections estimated the first galaxies would be small and faint, that JWST would find, at best, a few intriguingly remote candidates in its pilot investigations. However, things didn't quite go as planned. As soon as the telescope scientists released its very first images of the distant universe, astronomers such as Naidu at the Massachusetts Institute of Technology started finding numerous galaxies within them. Their apparent age, size, and luminosity surpassed all predictions. The competition for discovery was fierce, with each new day seemingly bringing claims of yet another record-breaking, earliest known galaxy emerging from one research group or another. The result, as Charlotte Mason, an astrophysicist at the University of Copenhagen, described, "Everyone was freaking out. We really weren't expecting this." In the weeks and months following JWST's findings of surprisingly mature early galaxies, theorists and observers scrambled to explain them. Could the bevy of anomalously big and bright early galaxies be illusory, perhaps due to flaws in the analysis of the telescope's initial observations? If genuine, could they somehow be explained by standard cosmological models? Or, just maybe, Were they the first hints that the universe is more strange and complex than our boldest theories had supposed? At stake is nothing less than our very understanding of how the orderly universe we know emerged from primordial chaos. JWST's early revelations could rewrite the opening chapters of cosmic history, which concern not only distant epochs and faraway galaxies, but also our own existence here in the familiar Milky Way. As JWST scientist Mark Makarian, a senior advisor for science and exploration at the European Space Agency, said, "You build these machines not to confirm the paradigm, but to break it. You just don't know how it will break." One might say JWST's observations of early galaxies have been billions of years in the making. However, more modestly, they trace back to the Space Telescope Science Institute, STSCI, in 1985. At the time, the Hubble Space Telescope was still 5 years away from launching on a space shuttle, but Garth Illingworth, then deputy director of the STSCI, was surprised when his boss, then director Riccardo Giccone, who passed away in 2018, asked him to start thinking about what would come after Hubble. "I protested, saying we've got more than enough to do on Hubble," Illingworth recalled. But Giccone was insistent. "Trust me, it'll take a long time," he said. So, Illingworth and a handful of others got to work drawing up conceptual ideas for what became known as the Next Generation Space Telescope, NGST, later renamed JWST after a former NASA administrator. Hubble would be transformational, but astronomers knew its capabilities would be limited by its observations in visible light. As light from a very distant galaxy travels across the cosmic abyss, it is stretched by the expansion of the universe, a broadening of wavelengths known as redshift. The higher the redshift value, the more stretching the light has experienced and, thus, the more distant its source galaxy. Redshifts for early galaxies are so high that their emitted visible light has stretched into infrared by the time it arrives at our telescopes, which is why Hubble could not see them. The NGST, in contrast, would observe in infrared and would boast a very large and very cold, star-like gathering mirror, allowing it to peer much deeper into the universe. Everybody realized that Webb would be the telescope for looking at early galaxies, Illingworth said. That became the primary science goal. The need for JWST was highlighted in December 1995 when astronomers pointed Hubble at a seemingly empty patch of the sky for 10 consecutive days. Many experts predicted the extended observation would be a waste of resources, revealing, at best, a handful of dim galaxies. But instead, the effort was richly rewarded. The resulting image, the Hubble Deep Field, showed that the empty spot was filled with galaxies by the thousands, stretching back to 12 billion years into the 13.8 billion-year history of our universe. There were galaxies everywhere, says Illingworth, now an astrophysicist at the University of California, Santa Cruz. The Hubble Deep Field showed that the early universe was even more crowded and exciting than most anyone had expected, offering observational treasures to those who took the time and care to properly look. Yet, impressive as Hubble's deep field was, astronomers wanted more. After more than 2 decades of labor at a cost of some $10 billion, JWST finally launched on Christmas Day 2021. The telescope reached its deep space destination a month later, where it would endure exhaustive testing to ensure its optimal performance. By July 2022, it was ready to begin its long-awaited first year of science observations, known as Cycle 1. Part of the telescope's early time was devoted to high-impact programs across a range of disciplines, from which data would immediately be made public. 2 of those programs, the Cosmic Evolution Early Release Science Survey, SEWERS, and GLASS, the Gravitational Lensing Amplified Survey from Space, independently spent dozens of hours looking for galaxies in the early universe by staring at separate small portions of the sky. Not much was expected, perhaps a slightly more ornate version of the Hubble Deep Field, but nothing more. Stephen Finkelstein of the University of Texas at Austin, the lead on CERS, says that extremely distant galaxies were predicted to pop up only after a few cycles of data from multiple programs. But much to the surprise of astronomers, extremely distant galaxies came into view immediately. Hubble's record for the most distant known galaxy had been GN-Z11, spotted in 2015 at a redshift of 11, thanks to a 2009 upgrade that enhanced the telescope's modest infrared capabilities. A red shift of 11 corresponds to a cosmic age of about 400 million years. a point on the brink of when galaxy formation was thought to begin. JWST's discovery of bright galaxies in the early cosmos challenges this model. We should see lots of these little protogalactic fragments that have not yet merged to make a big galaxy, says Stacy McGaugh, a cosmologist at Case Western Reserve University. Instead, we're seeing a few things that are already big galaxies. Despite the uncertainties, the rapid communication of new discoveries has invigorated astronomers. As we peer into the unknown, JWST raises new questions and challenges old paradigms. It's an exciting time to be exploring the cosmos.